Hello everyone, we are moving to section 3.4, area of a triangle. Here we are going to start with theorem. Area equals 1/2 b multiplied by h. What is b here? B is a side, h is a height from the opposite vertex of triangle on this side. So let's draw a triangle to show what is what on the picture. So b is side, right? From opposite vertex we are going to draw a perpendicular line, and this perpendicular line is going to make up our height. So formula is just height multiplied by side b divided over 2. Let's prove this simple formula. To do the proof, we are going to build two additional triangles. We are going to draw a horizontal line parallel to line b, and we are going to do the height, which is going to be parallel to the other, like two heights parallel to the height h. So we got two more triangles which are same to our like half triangles, right? I'm going to label them 1, 2, 3, and 4. And triangle 1 is equal to triangle 2 because sides are same. You see that the middle side is just belong to both of them, and opposite sides are equal. I'm labeling equal sides. Okay, triangles 4 and 3 are going to be also equal. Same reason, the height is same, and one side is, they share one side, and opposite sides are equal. All lines here are parallel and angles are 90 degrees. So basically these triangles are equal because three angles are same plus one common side. Well, if we consider all four triangles, we are going to have a rectangle, and the area of this rectangle is going to consist out of all these four areas: area of triangle 1 plus area of triangle 2 plus area of triangle 3 and triangle 4. So we know that 1 and 2 are equal triangles, so areas are equal. And because they are like equal, we can consider that it's two areas of triangle 2 and two areas of triangle 3. Triangles 2 and 3 are making up our actual triangle, right? The actual triangle is made out of two triangles, 2 and 3. So what we have, the two areas of our triangle, right? That means that the area of our triangle is 1/2 of area of the rectangle. What is area of the rectangle? Well, if you look at the rectangle, we're going to see that one side is equal to b and another side is equal to h. So we are going to just multiply them, and that's going to give us area of the rectangle. If we divide it by 2, we are going to get area of the triangle, and that's how we get the formula. Example number 1. In example number 1, somebody will give us side b equals 3 or equals 5 and h equals 3, and they're asking what is the area. Well, we just plainly use the formula. 1/2 5 multiplied by 3, we are getting 15 over 2, which is 7.5. The units are going to be square units of what was the units of sides. For example, if sides were in centimeters, area is going to be centimeters square. Okay, so example number 2. What if somebody gives us side and another side, but does not give us actually the height? So sides B and A are given, and also angle between them is given. Formally, this is angle C, right? Because it's a cross side C, which we are not using in this example. How do we calculate the area? Well, what we are missing is the height, right? If we draw the height and consider a right triangle, which is made by this height, and one of the sides has hypotenuse, we can say that this is opposite side, and if we do know hypotenuse, then opposite side equals hypotenuse multiplied by the sine of the angle, right? That's going to be our height, and now we can put this height into our formula. So A equals 1/2 B multiplied by A sine of t, 30 degrees. Well, that's a new formula we got. And it's not necessary that angle is going to be 30 degrees, can be anything else. I'm going to plug in the numbers for this specific case. So B equals 5 and A equals 6. 1/2 5 multiplied by 6 by sine of 30 degrees, which is 1/2. Everyone remembers from the table. We're going to get what? Like 2 cancels with 6 a little bit, so we're getting 5 multiplied by 3 divided over 2. We're getting again 15 over 2 or 7.5. The very same number we got from previous problem. Well, I designed it to get the same number. New formula which comes from this example is that area equals 1/2 B multiplied by A sine of the angle. Well, formally that's angle C, so sine of C. But you can remember it as sine between the sides. Okay, let's consider example 3. Example 3 is going to be more complicated. There are going to be 3 sides given and no angles at all. Side C equals 7, side A equals 4, and side B equals 5. Well, how do we calculate the area in this case? Well, we do have in the book Heron's formula, which is allowing you to calculate it, just plug in the sides. My suggestion to not use this formula because you will never remember it. So why don't we just apply a standard approach over here? You do know 3 sides and you need 1 angle. Well, how we do this? In the previous section of cosine's theorem, we learned how to calculate angle if you do know all 3 sides. I'm going to calculate angle B, but you can calculate any of 3 angles. You just need 1 for the formula, right? Well, cosine's theorem tells me that side B square equals A square plus C square minus 2AC cosine of B, from where I can calculate cosine of B, right? I plug in my numbers, so it's 16, no, 25 minus 16 minus 49 divided over minus 2, 4 multiplied by 7, and I'm getting 0.714, 0.714. That's a cosine, so angle is going to be actually cosine inverse of this number, 0.714, and I'm getting 44.4 degrees. That's my angle. Now I have everything what I need for my formula, for new formula. So area is going to be equal to 1/2 B multiplied by A and the angle between. In my case, my B and A are not actually going to be B and A for my triangle, right? They are going to be A and C actually. Remember that all formulas can be applied to any side, so it's not necessary to have sides A and B in the formula. So we have in this case A and C, and the sine of the angle between is sine of B. We plug everything in, use a calculator for sine of 44.4 degrees, and get the answer. It's going to be 979 square units. Now guys, I have a couple of problems for you to try on your own. So my suggestion, stop my video at this point, well, copy the problems, and then try to solve them on your own. After that, start the video again and compare my solution and your solution. It's going to be just next page. Okay, so first one, 3, 4, and 45 degrees, and the second one, 3, 3, and 2. 3 sides are given. I'm going to count to 5. 1, 2, 3, 4, 5, and we'll give you solutions. So, solutions. For the first problem, well, we just can use plain the formula, right? Just plug in everything. The sides are given, the angle between them is given, so we just use all this information, put in the formula, and calculate our answer. Okay, we got 6 over square root of 2, and we are moving to next triangle, which is consisting out of 3 sides. A equals 3, B equals 3, and C equals 2. I'm going to find angle C. Not necessary to find angle C, but that's just like my choice. So I'm going to use cosine's theorem for C square. Plug in the numbers, I'm getting 0.77 for cosine of C. And finding cosine inverse of this, I can find that angle C equals around 39 degrees approximately. Now I can again plug everything into my formula. The sides I do know are A and B, and the angle is C, so I'm just going to put 3, 3, and the sine of 39 degrees. You'll need to use a calculator, and after you plug everything